Now we talk about total internal reflection. So when the light enters from the optically denser medium to a optically rarer medium, it bends away from the normal. So denser medium to rarer medium would be, for example, from glass to air. So say you have glass here and this is air. So if the light goes directly on the normal, so this is the normal, that will go straight out. Yeah, there is no bending. Now if the light makes an angle with the normal, so say for example light goes like this, so if this is angle of incidence, it will get refracted. So what happens, it bends away from the normal. So this is say angle I1, incidence angle I1. Now if you increase the angle of incidence, so see the angle of incidence has been increased to I2 say, then the light will bend further away from the normal. So see, it has bent further away. So as I said before, part of the light gets reflected back, part goes through. Here again we are in the second ray here, so this was ray 1, this is ray 2. So part reflects back and part passes through. So as we increase the angle of incidence, this angle of refraction also increase. So if we keep increasing the angle of incidence, the angle of refraction will also increase till it reaches 90 degrees. So now at the angle of IC, so IC is called the critical angle. So if IC is the angle of incidence of the ray, so this is say ray 3, so this falls like this, part of it gets reflected back, and now at this angle the refraction takes place, and it is exactly this angle of refraction is 90 degrees. So here the angle of refraction was R1, this is R2. So as you're increasing the angle of incidence, the angle of refraction is also increasing. So I2 was greater than I1, and this would imply this R2 is greater than R1. So you keep increasing this angle of incidence, the angle of refraction also keeps increasing. So when it reaches 90 degrees, the angle of incidence is called the critical angle. So at this angle of incidence, which is called the critical angle, no light will pass to the rarer medium. So at this angle, see, there is no light which is passing to the rarer medium. It is just reflecting along the surface. Now this is called total internal reflection. Part of the light anyway gets reflected back, and although you are making an oblique angle with the surface, no light is passing through. So this is important. So no light is passing through. So you could basically pass the light through glass and no light will come to the air, because you have made an oblique angle which is equal to the critical angle at the interface of glass and air. So this is what is called total internal reflection, because all the light is reflected back. Notice that there is no mirror here. Just because of refraction, the light is getting reflected back. Now there are two important examples of it. One is Mirage. Now first thing is that these two figures are the same. So this Mirage is upside down figure of, so this is upside down of this figure. So you just flip this figure over and you get this figure. So flip it to get the Mirage. So how does that happen? So now you have high index here. So this is the denser material is here. So this is denser air because cold air is upstairs, and this is warmer air. So just like from here you go up and go down, from here this is just upside down figure like this. So here, from here, the light rays coming from here, they go down and then they bend and come up like this. Similarly from here they go down from the denser to the rarer material. So warmer air is rarer and it bends like this. So if it bends like this, so if your eye is here, so you take the straight line. So if you take the straight line, because to the eye you always see through the straight line, so you're seeing the straight line, it seems that the image is coming from here. So this is the Mirage. Now this total internal reflection is used in optical fibers also. So the light ray is passed inside the glass fiber and it keeps reflecting like this. So this is very important in communications. So long distance cables which are laid under the ocean are optical fibers. So they preserve most of the light.